all space enthusiasts, futurists, and fellow dreamers to a journey unlike any other. For decades, the phrase space race conjured images of Cold War superpower Sputnik and the giant leap for mankind on the moon. But what if I told you that we are in the midst of the second space race? One that's far more ambitious, far more challenging, and with stakes that are truly encompass the future of humanity. This isn't just about planting flags, it's about planting roots. It's about building a cosmic future, enabling permanent off world living, and unlocking the vast potential of our solar system. And guess what's fueling this audacious endeavor? The very power of the atom, which is fusion power and the nuclear propulsion. So, why now? Why a second race? The reasons are multifaceted. Our planet, while beautiful and bountiful, has finite resources. Humanity's population continues to grow, and critically, the technological hurdles that once seemed insurmountable for true interstellar or even interplanetary colonizations are beginning to yield. The first space race pushed the boundaries of chemical rockets. We got to the moon, a mere 3 day journey, but Mars, that's a minimum 6 months one way trip fraught with radiation exposure, supply chain nightmares, and immense costs. Beyond Mars to the asteroid belt or the outer planets, forget about it with the current tech. We need a game changer. We need a way to travel faster, carry more, and power truly self sustaining colonies. And that's the game changer, my friends, is hiding within the very core of the matter itself. Let's talk speed. Chemical rockets, for all their power, are relatively inefficient for deep space missions. They burn a massive amount of fuel just to get off Earth and accelerate a comparatively small payload. This is not feasible. Enter the nuclear thermal propulsion or NTP. This isn't science fiction anymore. It's a technology that has been studied since 1950s and now seeing a resurgence of interest. Instead of burning chemicals, an NTP engine uses a small, safer nuclear reactor to heat a propellant, typically liquid hydrogen, to extreme temperatures. This superheated gas is then expelled through nozzles, generating incredible thrust. The result? Up to twice the efficiency of the best chemical rockets. This means we could travel faster, cut travel time to Mars in half, reduce astronauts' exposure to harmful radiation, and dramatically decreasing mission cost and complexities. Imagine a journey to Mars taking just 3 to 4 months. And NDP is just the beginning. Even more advanced concepts like nuclear electric propulsion (NEP) would use a reactor to generate electricity, which then powers the ion thrusters. These engines provide less thrust but can accelerate continuously for long periods, leading to even higher speeds over vast distances. We are talking about reaching the outer solar system in a fraction of time currently required. This isn't just about convenience, it's about feasibility. Faster travel means less food, water, and oxygen needed for the journey, more efficient scientific exploration, and ultimately making regular, sustainable trips to our cosmic neighborhood, and it will be a reality. This technology is the key to unlocking the solar system. So, how can we get there faster? But once we arrive, how do we survive? How do how do we thrive? The answer again lies in the atom, but this time in its ultimate manifestation, which is the fusion power. Fusion is the process that powers the sun. It's the holy grail of energy, combining light atomic nuclei like isotopes of hydrogen to release colossal amount of energy with virtually no long-lived radiation waste. On Earth, we are still working on achieving net energy gain consistently, but in space, the rules and the needs are slightly different. Imagine a permanent Mars colony, a lunar base, or even sprawling space station up in the space. They will need enormous amount of reliable power for everything: life support, manufacturing, communication, mining, and creating resources like water, breathable air from local materials. Solar panels are good, but they are intermittent and less effective further from the sun, and certainly not sufficient for large scale industrial operations. A compact fusion reactor, however, could provide constant, abundant energy. It's essentially a miniature star, providing a virtually limitless power source from readily available fuels. Helium 3, a potential fuel for some fusion reactions, is abundant on Moon. Talk about local resources. This isn't just about electricity. Fusion power would be a complete game changer for off world living. It means we can build large, comfortable habitats, cultivate vast greenhouse, resource extraction and refining, and even propel incredibly fast interplanetary shuttles known as the direct fusion drives and take us further and faster than ever before. It's the key to making humanity a truly multiplanetary species. The second space race isn't just government agencies anymore. It's a vibrant ecosystem of public and private entities all pushing the boundaries. NASA, with its Artemis program, aims to return humans to the moon and establish a long term presence, paving the way for Mars. They heavily invested in the development of both nuclear thermal propulsion and advanced fission reactors for surface power on the moon. Private companies like SpaceX are revolutionizing launch costs with reusable rockets like Starship, making the deliveries of nuclear propulsion system and fusion reactors to space more feasible. Other companies like Blue Origin are also developing advanced landers and heavy lift capabilities. On the nuclear tech front, companies like X Energy and BWXT are working on compact fission reactors for space power. And in the realm of fusion, startups like Helion, Commonwealth Fusion System, and General Fusion are making rapid progress, pushing us closer to the commercial fusion power here on Earth, which will inevitably translate to compact, robust design for space. This isn't just an American or a European race, it's a global endeavor. International partnerships are crucial, sharing knowledge and resources to tackle these monumental challenges. The monument is huge and the momentum is undeniable. The vision is clear: bustling cities on Mars, research outpost on the moon, mining operations on asteroid, and human exploration reaching beyond our wildest dreams. But it's not without any challenge. Developing safe, reliable nuclear systems for space, mitigating radiation exposure for long duration mission, and perfecting the closed loop life support for permanent colonies are monumental tasks. We also need to establish international regulatory framework for nuclear activities in space to ensure safety and prevent conflicts. However, the opportunities far outweigh the difficulties. The second space race is about more than just technologies, it's about inspiring a new generation of scientists, engineers, and explorers. It's about securing humanity's long term future, safeguarding us against the existential threat, and perhaps one day venturing to the stars themselves. The second space race is not just a technological competition, it's a redefinition of our place in the cosmos. With fusion power providing boundless energy and the nuclear propulsion offering unprecedented speed, we are on the cusp of truly building our cosmic future. The next chapter of human history will be written not just on Earth but among the stars. Are you ready to witness it? If you're excited about this future, hit that like button, subscribe to the channel, and share your thoughts in the comments below. What part of this cosmic future excites you the most? Thank you for joining live. Thank you for watching. And I will see you next time on the same frontier, which is the final frontier. Bye for now.